Lesson 7.2 is properties of exponential functions. We're doing a little bit more with graphing is what it comes down to. Today we are more focused on, okay, how do we do the stretch and shrink? How do we do the translations? How do we put it all together? So we're really still focusing on that. Keep in mind, this is all based on, given the parent function, y equals b to the x. So these are all exponential functions. It's all some number raised to a power of x is what we're looking at here. A little bit of review from first semester. If y equals a times b to the x, what does an a value out front do? Well, generally talking, an a value out front is either going to stretch or shrink, isn't it? Depending on what that a value is, it's going to stretch or shrink. Now, I skipped over the first part. What if that a value is negative? If it's a negative value out front, then it's going to reflect. So a negative value out front is still going to reflect our graph. What kind of numbers give me a stretch? Don't think greater than 0, though, because that's a typo. 1. Greater than 1, does that sound familiar? Because think about this. If a stretch is greater than 1, what have we said for a shrink in the past? Numbers between 0 and 1, right? So that's kind of a typo, sorry. But what this should say, it says the absolute value of numbers greater than 1. That's just saying if there's a negative that's reflecting it, look at the number without the negative. So a number that's greater than 1 is going to stretch it. A number, what we usually say is between 0 and 1, yes? A number between 0 and 1 is going to shrink it. That's also the same as saying a number, the absolute value of a number less than 1. So just kind of remember those rules from first semester, and we've even talked about them last chapter with the square root graphs. The next part here, if you have a times b to the x plus or minus h, notice, where is that h at? That h is in with the x, yes? It's kind of like it's in parentheses with the x, in the absolute value with the x, in the square root with the x. In this case, it's in the exponent with the x. When the number is added or subtracted directly to the x, what directions does that take us? That's going to either take us left or right. And what do I usually tag on to that phrase? Left or right and opposite the sign? Where are you guys today? You guys are quiet all of a sudden.
It's Tuesday. It's been
That's been the excuse all day. It's Tuesday.
And it's been a while.
See, but you guys were very talkative before I started the lesson. So, okay. So remember, if it's added or subtracted directly to the x, it's left or right, opposite the direction of the sign, right? So if this is a plus h, that means our graph is going to go left h. If it's a minus h, our graph is going to go right h. So that's if it's directly with the x. What if there's a number just added or subtracted at the end? Plus or minus k is going to be up or down, yes? If it's at the end, away from everything else, that's just up or down. The direction of the sign, so plus k means up k, a minus k means down k. That's kind of review in a way. It's just putting it in a new situation. Now, we're going to look at some of these graphs. As I said, there's 6 graphs. We're not doing all 6. I have 3 planned. And example A right here is the first graph we're going to look at. Y equals negative 1/3 times 3 to the x. I have B blacked out because we're not going to do B. And I'm going to use this space for work. And my morning class was having a really hard time seeing when I wrote on top of the graph. So this is why I whited out my graph. Okay, you guys, I would encourage you use your workspace there for the graph. Now, as we look at A, y equals negative 1/3 times 3 to the x. What transformations do you see? Okay, she sees a negative out front, which is a reflection. So there is going to be a reflection across the x-axis. What'd you say?
Vertical shrink.
Vertical shrink? Very things out there.
You did. Somebody will come up.
I know, but they like hit something or whatever, but
We're stopping.
okay. Okay. The 1/3, when you multiply by a number that is less than 1, that is a vertical shrink. So one of the things you need to be able to do, notice it says what translations affected the parent function. You need to be able to put these in words, right? You know, in Math Excel, it's probably going to be more of a multiple choice, pick what they say. For a quiz or a worksheet or something, I'm going to ask you to write them out. You have a little bit more room below here than what I did, but I'm going to write them out in terms that this is reflected, and specifically we're reflecting across the x-axis, and, dang it, there is I'm squishing this in, sorry, a vertical shrink, and that is by a factor of 1/3. Sorry. You guys have a little bit more space because you have space between that graph and the next graph, right? Hopefully you can get yours in a little bit better, but I will read that again. Reflected across the x-axis and vertical shrink by a factor of 1/3. Sorry, that's really horrible as I turn to look at it, but. Okay, well, she says it's at least somewhat readable.
That's how all my tests actually look.
I guess I do have to read your guys' handwritings, right? So. Some of you guys have great handwriting. Some of you guys, well, you know, we make it work. Okay, now we get to graph it. In order to graph this, we're going to go the XY chart route. And on all of them today, we're going to go the XY chart route. This one, because it is a reflection and just a shrink, we're going to put the whole thing into an XY chart. If there are some that involve translating, so moving left and right specifically, and up and down, we won't put those in the XY chart. We'll move those afterwards. What kind of X values are good here? Actually, multiples of 3 would get me too big. Because keep in mind, what am I going to be doing with whatever number I put in here?
Wouldn't it just be
Multiples of 0.3.
1, 0, 1, 2.
0, 1, 2, and
Negative 2, 1.
I have to say negative. I know, none of us want to think negative, but we have to. So I'm going to use negative 2, negative 1, 0, 1, and 2. And I'm just putting this into the whole original function. What is my whole function? Negative 1/3 times 3 to the x. What's our first x value we're going to put in here? Negative 2. Okay. See if you can think without the calculator first. How do we deal with a negative exponent? Yeah, you move it to the denominator and it goes under 1, yes? So I'm going to keep this as negative 1/3. So 3 to the negative second is really going to be 1 over 3 to the second. So negative 1/3 times 1 over 3 to the second. So negative 1/3 times 1 over, what's 3 to the second? 9. What's negative 1/3 times 1/9?
Negative 1 over 27.
Negative 1/27. So negative 1/27. Yes, there's a decimal equivalency of something. I don't know what right offhand, but
That one might be a little tough to grasp.
it is going to be tough to graph. Which, by the way, I apologize for the grids to begin with. They're horrible today. I will admit it. They're going to be rough, but we're going to survive. Okay, now what? Now I repeat the process. This time, what goes in for x? -1. This first graph is just rough all the way around. It really just is.
I don't understand why we have to know. I know this sounds like I'm not trying to be like, my brain is just like, why do we have to know, like, how to.
Like these y values, or?
Yeah, with a fraction, like, I don't understand why it has to be so difficult.
Well, and you can do the decimal. Because in all honesty, when it comes to Math Excel, they're going to be giving you a graph. They're going to be, Math Excel is probably going to be doing multiple choice here, and which graph matches is what they're probably going to do. Okay? I wouldn't give you something like this on a worksheet or on a quiz or a test. I'd make it a little easier than this. Because this gets it's doable.
Yeah.
But I would try and make it a little easier on you. Okay?
You do the first.
The good news is you have me to lead you through this one, right?
Yeah, that is good.
I know it's discouraging. It's work, but it's doable. You guys can do this. Okay. 3 to the -1. How do I deal with 3 to the -1?
Just 1/3.
Yeah. So we still have -1/3 out here. 3 to the -1 becomes 1/3 to the first, if you want to get particular there. What is -1/3 times 1/3? -1/9. Okay, it gets easier from here on out, I promise. -1/3 times 3 to the 0. What's anything raised to the 0? 1. So then this is -1/3 times 1. What's -1/3 times 1? -1/3. See, that wasn't as bad, right? Next one isn't that bad either. -1/3 times 3 to the first. Well, silly question. What's 3 to the first? 3. So what is -1/3 times 3? So 3 as a fraction is 3/1. What's a third of 3? -1? It's -3/3 if you want, but it becomes -1. And let's plug in 2. -1/3 times 3 to the second. -1/3 times, what's 3 to the second? 9. 9/1, if you will. What's a third of 9? 3. A negative times a positive is a negative. Now, as we get ready to graph this, do you remember what these graphs looked like in lesson 7-1? If you remember, the basic graph in 7-1, I'm going to erase this so you don't need to write this, but the basic graph in 7-1 did what? It ran along the x-axis, crossed through, and went up and away, right? That was the basic graph in 7-1. Now, here's the deal, guys. This graph shrinks, so it's just not going to go up as quick, and it has a reflection. What's going to happen when we reflect it? Instead of being above the x-axis, it's going to be below the x-axis. So as we go through and do this, yes, it's going to be below the x-axis. So where is -2, -1/27? Okay, left 2 and down a, what is it, teensy bit? Teensy weensy bit. Okay. This morning it was down a smidge. Whatever makes you happy there. -1, -1/9. Left 1 and Down a little teensy-weensy bit. What about 0, negative 1/3? Left to right 0 and technically down 1/3 of a box. It's hard to do that on, especially on here, but it's even hard to do that on your paper, isn't it? Those aren't a straight line, but they kind of look like it. Okay, we're going to correct that here. 1, negative 1. Right 1, down 1. 2, negative 3. Right 2, down 3. Okay. Can you see the shape of the graph happening there? What's it going to do? As it goes off to the left, it's going to run alongside the x-axis, never crossing, never touching. As it goes off to the right here, it's going to run down. Keep in mind, it's upside down because this was reflected across the x-axis. So it's going to run below the x-axis, never crossing, never touching. Yes, Levi? Did you answer your own question in there?
Yes.
Okay. Okay. Questions on this one? Okay, well, moving down, we're going to look at C on the next part. And skip D. You guys have what you need on this screen? I got rid of the graph. Not that I need as much workspace on this one. You'll like the math much better on this one, okay? Yes, we still have to work with negatives, but it's not as bad. Now, as we start looking at this one, y equals 2 times x to the minus 4. What transformations do you see here? Do we agree? She says right 4. It's a minus 4 in with the x. And so that does mean that we are going to move right 4. The 2 is just your base. It's 2 to the x. There's nothing out front of the 2. No stretch, no shrink, no reflection. So the only thing we're going to do with this graph is it's going to be translated right 4 units. So I'm going to write that out. So translated right 4 units. Now, this is the type problem. It is important that we do not just put our x values into the equation and work it, because you won't get an accurate picture of the graph. I still want to use -2, -1, 0, 1, 2, but the part of the graph I'm going to use is just y equals 2 to the x. Because what can I do with those points after I get the points for y equals 2 to the x? Move them right 4. So what we're going to do is we're going to graph y equals 2 to the x, and then we will move right 4. That's my plan. So we're going to graph y equals 2 to the x and move right 4. I'll be honest, up and down, you would be okay to put everything in the XY chart. This one specifically, you will not get an accurate graph if you try and put the whole thing into the XY chart. Okay, and I'll try and explain that at the end. Now, what x values are we using? Still -2, -1, 0, 1, and 2. Except what am I putting these into? We're just doing 2 to the x. Set aside the -4 We'll move right 4 at the end. So, if we're doing 2 to the x. Okay, guys, use those brains. How do I deal with 2 to the negative 2? Negative exponent goes to the denominator, right? So 2 to the negative 2 becomes 1 over 2 to the positive 2. What is 1 over 2 to the positive 2? That is 1/4.
These problems always set you up to have a fraction. It's horrible.
We are stuck working with fractions here. I can't get us out of that. What about 2 to the negative first? Move the negative to the denominator. It's 1 over 2 to the first, which is 1/2. Okay, join me on the next part if you haven't liked the last 2 parts. 2 to the 0. Anything raised to 0 is 1. 2 to the first. 2. 2 to the second. 4. They got better as we went along, didn't they? Okay, what did I suggest we're going to do? Graph these and then move them right 4. Or if you want to graph them, move them right 4 as you graph them, that's fine. So, negative 2 1/4. Left 2. Up a teensy weensy bit. Is that the right vocabulary for this class?
Yep.
Okay. Negative 1 1/2. Left 1. Up a half. I guess it's still that teensy weensy bit, isn't it? The 0 1. Left to right 0, up 1. 1 2. Right 1 up 2. 2 4. Right 2 up 4. Don't stop there. What do I do with those dots? Move them all to the right 4. So, if I start with the dot I just ended at, I was at 2 4. If I move it right 4, I end up at 6 4. 1 2. I move that right 4, I end up at 5 2. 0 1. If I move that right 4, I end up at 4 1. Negative 1 1/2. If I move that right 4, I end up at 3 1/2. And negative 2 1/4. If I move that right 4, I end up at 2 1/4. Those red dots are my answer. Okay, those red points are my answer. What are we running alongside? Never crossing, never touching? The x-axis. As we go up to the right, it's going to go increasingly up. So we took these dots right here, and then we moved 4 right. And I don't know if this will make sense to you. But think about it. We like to use the points negative 2, negative 1, 0, 1, 2, correct? If I would have just used those, look at my red graph. What do you notice about the points from negative 2, negative 1, 0, 1, 2 on the red graph? They would have never gone above 1. If we would have just put in negative 2 through 2 in here, It would have looked like a straight line, guys. Which is why I strongly encourage, when you have especially those left and right translations, you've got to pull those apart and do those separate. Okay? Okay. One more graph on the back side. And it is the one on the right labeled E. Alphabetically, it should be F, but that's a whole other point. So we're going to look at E. Okay. What can you identify on y equals 5 times 25 hundredths to the x plus 5? What can you identify there, Doug?
It is a vertical stretch of 5.
Okay. There's a 5 multiplied out front. It does indicate that this is a vertical stretch. What else?
Just gonna go up 5.
There's a plus 5 at the end, which is up or down, direction of the sign. So we're going to go up 5. Okay. So if you're writing out your transformations, which you need to be in the habit of knowing what they are, vertical stretch by a factor of 5 and translated up 5 units. So vertical stretch by a factor of 5 and translated up 5 units. That's my 11-minute warning. Got it. What am I going to suggest we use the XY chart for? Okay, I'm going to suggest that this part right here is what we do the XY chart for. And then we'll take those values and move them up 5. Okay, so that's my recommendation. So XY, what X's are we using? -2, -1, 0, 1, 2. And again, I'm just using the 5 times 0.25 to the x. We'll move up 5 at the end. Now, you want to speed things up and go the calculator version on this one?
Nope. Get 80.
You can put it in the calculator here. 5 times 0.25 to the -2. Unfortunately, Levi is right. What do you guys try it? Make sure you know how to use the calculator. When you put in -2, you do get 80. Okay? Because 0.25 is 1/4. 1/4 when you flip it upside down is 4. 4 squared is 16. Times 5 is 80. Okay, put -1 in. 20. We'll adjust our graph. I'll make it work. You could technically put 0 in without your calculator. 0.25 to the 0 is 1. 5 times 1 is 5. 0.25 to the first is just 1/4 times 5. So you could say 5/4. Your calculators are probably telling you 1.25 though, aren't they? 1 and 1/4, same thing. Okay. If I put in 2, it becomes 5 over 16, which is 0.3125. Okay. Now, the problem that some of you don't like is We have to graph up to 80. Technically, we have to graph up to 80 plus 5. So we have to graph up to 85. Obviously, my graph is not set up for that. What I'm going to do is I'm going to scale my graph. You guys know how to scale a graph. What works relatively well is if I count by 5s. And what I'm doing is just right in this area, I'm labeling, but I'm going to label every other line. So here's x-axis is 0, first line is 5, then I'm going to label 10. Let me get black instead of that gray. So 5, I'm going to label 10. Skip a line is 15, label 20. 25, label 30. 35, label 40. 45, label 50. 55, label 60. 65, label 70. 75, label 80. If you do it my way, you get 80 as your top line. We can scale graphs, guys. That's okay. You just have to label how you're scaling your graph. Okay. Negative 280 says I'm going to go left 2 and up 80. So the very top line on my graph. Negative 120, left 1, up 20, which is up 4 boxes on mine. 0, 5, where is 0, 5? My first line is 5, so it's up 1 line. 1, comma 1.25, so right 1 and this is the up a teensy weensy bit because that first line is 5, so we're not even going anywhere close to that first line. And then 2 and 0.3, well, that's right 2 and up a teensy bit. Officially, what do I have to do to finish this graph? Yeah, you're going to take these values here and move up 5. What is moving up 5 on this graph? 1 line. So my 80, I'm just going to kind of draw it in there, 85. 20 moves to 25. 5 moves to 10. And those two move, instead of being right above the x-axis, they're right above 5. Okay. Those red dots are my line, or my graph. What line am I never crossing, never touching? Ah. It looks like 1. It's technically 5 because of how I'm labeled. Realize it's not the x-axis this time, is it? Because my graph did what? It went up, didn't it? Since my graph moved up, it's not the x-axis, it's that next line up because we moved 1 line up. Okay? Okay. I think you guys should all be in here tomorrow, but real quick, I'm going to address the bottom section. Just because when you go to do homework, which you'll have time to work on in class tomorrow, you need to be familiar with the E button. So when we talk about compound interest, specifically continuously compounded interest, there's a special formula, and it's A of t equals P times E to the RT. E being a button on your calculator. Okay? P is your principal. That's your money. R is your annual interest rate, which is your percent. And T, of course, is time. Look real quick with me at this one, because it is really a quick question. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school in 4 years. Well, because it said compounded continuously, the formula I'm using, A of t equals P times E raised to the RT. Okay. What is 3,000? You've done interest before. That's your P. That's your amount that you start with. What is 5%? That's your R, except what is 5% as a... You didn't say 1, did you? Just 0.05? Just 0.05, right? And then high school, or 4 years, means that is your T. Fill in your formula, guys. You're just trying to find A of 4. We're not going to do anything with A of 4. We're just trying to find A of 4. P is 3,000 times E to the 0.05 times 4. It's all about the calculator. Look for a little e to the x button on your calculator. Mine is right above ln. There's my e to the x, and that's what I'm going to use. Okay? So I'm going to type, what's my problem? 3,000. Then what are we doing? Times e. So e, notice it automatically, mine honestly says e to what power? Then I'm going to type 0.05 times 4. And I can hit enter there. If you get your calculator figured out, your answer will match mine. And I can definitely help you guys figure calculators out tomorrow. But that is $3,664.21. By all means, you have some problems in homework. If I recall, this is the homework where you just have to find e to some power possible. So, know how to use your calculator. That is something you'll have to know. Again, I can help you with your calculator individually tomorrow. Okay? Remember, tomorrow will be somewhat of a work day for those of you in class.